morning. Welcome back. Today our topic is the relationship between relative molecular mass and molar mass. Relative molecular mass and molar mass. The last time we talked about relative atomic mass of an element and how to find the atomic mass of an element. Today we are going to start with molecular mass. What is the meaning of molecular mass? Molecular mass simply means the mass of a molecule or a compound. Example, water is a molecule. The mass of water is the relative molecular mass of water. The mass of sodium hydroxide, that's caustic soda, is relative molecular mass of caustic soda. Then, how do you obtain the relative molecular mass of a compound? Relative molecular mass is obtained by adding the masses of the individual atoms that make up the compound. For instance, water molecule is represented as H2O, that's the chemical formula. In this compound, we have hydrogen and oxygen. And we have 2 atoms of hydrogen and 1 atom of oxygen. Therefore, the molecular mass of water is the atomic mass of hydrogen plus the atomic mass of oxygen. Here we have 2 atoms of hydrogen. That is why I wrote 2 times H. And we have 1 oxygen, that's why I said plus oxygen. So the individual masses, the mass of hydrogen plus the mass of oxygen will give you the relative molecular mass of water. So this is 2 times, if you look at the screen, I gave the atomic mass of hydrogen and the mass of oxygen. So 2 times H, that's 2 times 1, because 1 is the atomic mass of hydrogen, plus the atomic mass of oxygen is 16, so we have plus 16. Adding them together will give you 18. Therefore, the molecular mass of water is 18. What is the molecular mass of ammonium chloride? The chemical formula of ammonium chloride is NH4Cl. And from this chemical formula, you will find out that this compound contains nitrogen, hydrogen, and chlorine. Therefore, the molecular mass of ammonium chloride will be the sum of the masses of the individual atoms that make up the compound. So the mass of nitrogen plus the mass of hydrogen plus the mass of chlorine. So the mass of nitrogen, according to what I gave on the screen, is 14 plus the mass of hydrogen. But in the compound, you have 4 hydrogen atoms, so it will become 4 times the mass of hydrogen, so 4 times 1, plus the mass of chlorine is 35.5. So this will give you 14 plus 4 plus 35.5, which will give you 53.5. Okay, let's solve more problems on this. Calculate the relative molecular mass of the following compound: calcium trioxynitrate 5 and ammonium trioxycarbonate 4. This is the chemical formula of calcium nitrate, and it contains calcium, nitrogen, and oxygen. If you look at this, we have only 1 calcium atom. Then in brackets, we have nitrogen and 1 nitrogen and 3 oxygen atoms. Enclosed in this bracket, we have 2 outside. We have 2 outside the bracket, and this 2 is meant for everything enclosed in the bracket. It's meant for nitrogen and oxygen. Therefore, the relative molecular mass of calcium nitrate is the mass of calcium plus, which is 40, plus, in bracket we have nitrogen, which is 14, and oxygen, 3 atoms of oxygen, so you have 3 times 16, because the atomic mass of oxygen is 16. Then, enclose everything in brackets and multiply by 2, because according to the chemical formula, everything in brackets is multiplied by 2. So you multiply the items in bracket by 2. So we have 40, we bring down our 40 plus 14 times 2, because I'm applying everything, will give you 28, plus 3 times 16 is 48, times 2 will give you 96. If you add this together, you have 164. So the molecular mass of calcium nitrate is 164. Okay? Then the second one says the molecular mass of ammonium carbonate. If you look at this compound, it has nitrogen, hydrogen, carbon, and oxygen. Then in bracket you have nitrogen and hydrogen multiplied by 2. So we bring it out here. We have in bracket nitrogen plus 4 atoms of hydrogen, which is 4 times H. Then enclose everything and multiply it by 2. Plus this carbon here, the mass of carbon, plus 3 atoms of oxygen. So the atomic mass of nitrogen is 14, plus 4 times 1, which is the mass of hydrogen. Then everything in brackets is multiplied by 2 according to this. So we multiply everything in bracket by 2, plus the mass of carbon, which is C, 12, plus the mass of oxygen, which is 16, but we have 3 atoms of oxygen, so we have 3 times 16. If you sum this up, you have this 14, to multiply everything, you have 2 times 14, plus 2 times 4 times 1 from this, then plus our 12, plus 3 times 16. So if you sum this up, you have 96. So the molecular mass of ammonium carbonate is 96. Now, what is the relationship between molecular mass and molar mass? The molar mass of a substance is the relative atomic mass or the molecular mass, the relative molecular mass of that substance, expressed in grams. Once you express atomic mass or molecular mass in grams, you are talking of the molar mass. For instance, the relative molecular mass of sodium hydroxide is 40. From this calculation, you will have 40. The molar mass is 40 grams. Are you getting it? The molar mass is 40 grams. The relative molecular mass of calcium nitrate is 164, as we've calculated earlier. The molar mass is 164 grams. Here, the relative atomic mass of potassium is 39. Once you add gram to give you 39 grams, we are talking about molar mass. So the molar mass of potassium is 39 grams. The relative atomic mass of copper is 63.5. The molar mass is 63.5 grams. So once you express atomic mass or molecular mass in grams, you are talking of your molar mass. Since molar mass represents the mass of 1 mole, the unit of molar mass can as well be written as gram per mole. In short, in chemistry, we usually write it as gram per mole, since molar mass represents the mass of 1 mole. Don't worry, the next video will be on mole concept. That will explain what mole means. For instance, sodium hydroxide, the molecular mass is 40. The molar mass is 40 grams per mole. I hope you understand. Good. Study question. Calculate the relative molecular mass and the molar mass of the following: potassium tetraoxosulfate 6 and sodium trioxocarbonate 4, aluminum oxide and ammonium tetraoxosulfate 6. I want you to follow the same procedure and calculate the molecular mass first and then tell me the molar mass. Okay? If you have any question, you ask me. Thank you for listening.